for you. Today we discuss variation of acceleration due to gravity with respect to the height from the ground. So what is acceleration due to gravity? You have studied in lower classes that if a body is dropped from a height, it is found to be accelerating downward by the attraction of Earth alone. That particular attraction or that particular acceleration with which a body is falling towards Earth under the attraction of Earth alone, we call it as acceleration due to gravity, denoted by G. Acceleration produced due to the force of gravity. That means, whenever Earth attracts another object, that attractive force we call it as force of gravity. So, here the acceleration is produced due to the force of gravity, so we call it as acceleration due to gravity. And the value of acceleration due to gravity on the surface of the Earth is given by the formula, that is G equal to capital G into ME by RE, where ME is the mass of Earth, RE radius of Earth, assuming Earth to be a uniform sphere. Then the acceleration due to gravity on the surface of Earth, we consider it to be a constant approximately, and that is given by G equal to capital G into MV by RE square. RE square. So this is equation 1. That is acceleration due to gravity on Earth. G equal to capital G into ME by RE square. Now, suppose I take the point from here up to this point, then the attraction between the mass and this Earth will be having a distance of center to center, that is RE plus H. And from this equation it is understood that acceleration due to gravity depends on distance from the center of the Earth. And therefore, we can write the equation for acceleration due to gravity at that height h will be equal to acceleration due to gravity at height h, that is G prime will be equal to capital G into ME divided by RE plus H the whole square identity. So from this equation one thing is clear that as we go away from the acceleration due to gravity is found to be decreasing. But what we want to find here is the variation of G with respect to height. For that, we have to combine the two equations, and I take equation 2 by equation 1, then we get G prime equal to capital G into RE square by RE plus H the whole square. So this is one equation we can consider for variation of acceleration due to gravity with respect to height. Now there is a small problem there. Here RE plus H is coming, therefore we can see as the H increases, RE plus H will be increasing and the denominator altogether increases and therefore value of G prime will be going on decreasing. Okay. So as you move away from the surface of Earth, you can find that acceleration due to gravity is decreasing. It's on this equation. But there is a small problem there. If I take H very small compared to RE, if I take H very small compared to RE, then what happens here? RE is of the order of, value of RE is coming of the order of 6,400 kilometers. Now compared to this large value, suppose I take H is small, then here you can find that G prime will be equal to G because RE plus H becomes RE itself. So RE square by RE square. So G prime will be equal to G. So for small heights, if we consider this particular equation, the value or the variation in G is not seen. But that is not true. Whatever the height be, whether it is small or large, there will be a variation in acceleration due to gravity. So to get the variation with respect to a very small height, this equation is not applicable. This equation is applicable only for RE, which is comparable to, for this equation is applicable for H, which is comparable to the radius of Earth. Means H is comparable with the radius of Earth. Large heights only this equation is possible. Now how we can use this particular equation for finding the variation for small heights? So we got the equation for G prime will be equal to G into RE square by RE plus H the whole square. And if we consider the case H, which is very small compared to RE, we have to rewrite this equation as G prime equal to G into RE square divided by RE square into 1 plus H by RE the whole square mathematically. Because RE plus H the whole square can be written like this. Now, what remains here is this one and this one will be going, and we will be getting the formula G prime will be equal to G into 1 by 1 plus H by RE the whole square. That is 1 divided by 1 plus H by RE the whole square we get. Now, I can take the formula in this form that G prime equal to G into 1 plus H by RE whole raised to minus 2. Because I can take this to the 1 by to the numerator, and then what happens is this minus 2 becomes minus 2. Okay? Now, we'll be using the binomial expansion here, binomial expansion, and I'm not going to in the details of those things and all. So if we try to expand this, we will be getting G prime will be equal to G into, first function will be 1 raised to minus 2. So it is 1 itself. Then minus 2 will be coming along with us, that minus 2 times h by Re, and next will be plus higher powers of h by Re will be repeated afterwards. So we will be limiting our discussion here, and we get an equation like this for the variation in acceleration due to gravity with respect to height, which is small compared to Re. Now what is the difference you find with this one? This equation is not applicable because Re plus h is coming together. So you can compare h with Re. But in this case, h and Re are not comparable because it is coming in the form of a fraction here, h by Re. So whatever or however small this h be, you cannot treat it as what? 0 d. So this equation you can apply for very small heights. Now let us see how it is. See, h, if it goes on increasing, what happens is h by Re will be increasing, thereby 1 minus h by Re decreases, and therefore acceleration due to gravity goes on decreasing. So you got two equations. One is this one, that is applicable to large heights or heights comparable to radius of Earth, and here this is height comparable to, or height which is negligibly small compared to the radius of Earth. Okay? So when you do the sums using this power, this with respect to height, you must be identifying whether the height is negligible or comparable with the radius of Earth, and then only you can choose the equations properly. Okay?